Okay, this is our group member, which is first is Muhammad Rizqal Sham, our group leader. Second team is Muhammad Adi Shamil, and third team is Muhammad Al-Mahimi is me. Fourth is Muhammad Hakim, and lastly, the group member of this is Muhammad Afid Hakim. Okay, that's all for me. Okay, Assalamualaikum. My name is Aiman. I will proceed with the theory. Which is the theory of this cylinder experiment is typically referred to the mechanical engineering experiment, which is to study the behavior of thin-walled cylinder under various loading conditions. First is material characteristic. The material of a cylinder, which is a yield strength, Young modulus, and Poisson ratio, are actually the mechanical characteristic that affect how the material behave under load. The second thing is a geometry, which is the cylinder, thickness, radius, and other parameter all have impact on how it respond to applied stresses. Lastly, about this story, which is a boundary condition, uh, the cylinder deformation and stress distribution are influenced by how it is supported and restrained. For instance, the cylinder behavior may be greatly changed by the state of its end, whether they are closed or open. That's all for me. Thank you.
So this is the result for the thin cylinder experiment. For the table 1, result for thin cylinder with open end, which is pressure from 0.5, 1.0, 1.5, 2.0, 2.5, and 3.0. While for the table 2, this is the result for thin cylinder with closed end, which use pressure 3.0.
Now we move to the calculation part. But first, let me introduce myself. My name is Muhammad Rizqal Sham, and I'm going to present the calculation part for thin cylinder experiment. So in the experimental setup, the wall thickness is equal to 2.5 millimeter. The inner diameter of the thin cylinder is equal to 72.5 millimeter. Young modulus equal to 70,000 Newton millimeter square. And lastly, the Poisson ratio is equal to 0.33. So in this calculation, we will calculate the open ends and the closed end conditions by using all of the information given. In closed ends, we will going to use the formula of hook stress and the longitudinal stress, but in open ends, the longitudinal stress is equal to zero because there is no obstruction to the end of the cylinder. So as you can see in this slide, these are all the data that we got from our experiment to get the theoretical values. After calculating, these are all the results that we got. So in order to calculate the open ends, we will find the hook strength and the longitudinal strength for this open end. So firstly, we will going to use the formula of hook stress, which is PD over 2T. And then we're going to use the we will going to use the hook strength formula. And lastly, we use the longitudinal strength. By using all of the data, we will finally get the hook strength and the longitudinal strength for each of the pressure given. And that will be the theoretical value for this experiment. Now we jump to the closed ends condition. In this condition, we will use both of the strain formula, which is the hook strength and the longitudinal strength. We will use all of the data given, same like the open end, but this time the longitudinal stress will not equal to zero. So we need to use the formula of PR over 2T. So this is the theoretical value of the open ends when the pressure is equal to 3.0. So that will be the end for this calculation part. That's all for me. Thank you.
Hi, I'm Aminuddin. I will talk about observation for thin cylinder with open end have 3 points. For the firstly, the pressure external of external air pressure can cause the cylinder to expand, deform, or rupture if the material strength is efficiency. For second, the tension force pulling along the length cylinder can scratch and thin the material potentially leading to failure. And thirdly, for compression, force pushing along the strength can cause bulking or crumpling, especially if the cylinder are thin. Okay, now I will talk about the cylinder closing end. Firstly, the Hooke stress, the consumption stress cutting perpendicular to the cylinder's axis. For secondly, perpendicular stress, the exertion stress acting along the length of cylinder. And third, the elasticity influence the material ability to deform under the stress and return it to original shape and when it is removed.
For discussion, we have discussed two questions. First, explain the differences between the open end and the closed end condition. For the open end condition, in this condition, the cylinder has no axial load, meaning there is no direct axial stress along its length. The cylinder wall will experience only tangential stress due to internal pressure. The stress rate is unaxial, with maximum stress being a tangential stress. In this condition, the radial stress is zero. In this condition, the more circle representation show only one principal stress, which is tangential stress. Next, for closed end. In this condition, the cylinder has axial load resulting in direct axial stress along its length. The cylinder wall will experience both axial, longitudinal stress and tangential stress due to internal pressure. The stress state is biaxial, with both axial and tangential stress playing a role. In this condition, the maximum and minimum principal stress occur in the principal planes, usually at 45 degrees to the axial direction. For closed-end condition, the more circle representation show both principal stress. For the next question, which case experience unaxial state of stress and which case experience biaxial state of stress? So, in the thin cylinder experiment, the open end will experience unaxial state of stress and the closed end will experience biaxial stress of stress.
Okay, lastly, for the conclusion of this experiment of this cylinder is actually the relationship between the parameters suggests the hypothesis, and the experiment was successful finish. However, additional data and repeated tries may increase accuracy. We have achieved the experiment initial goal, which is the graph stress and strain have the relationship is correct because of its linearity. Lastly, the data is accurate, followed by the collection requires that's observation of the hydraulic hand pump and the pressure gauge. That's all from us. Thank you.